Welcome to the final episode of the Pure Storage Non-Disruptive Everything video series. In episode 3, we will demonstrate a non-disruptive upgrade from the FlashArray M20 to a FlashArray M50 and add capacity to the system. In this video, we will show an in-generation upgrade from a FlashArray M to another FlashArray M. No disruption, no data migration, no rebuy of hardware and software. As the series discusses, this is all a new and unique ownership experience that Pure Storage is delivering to its customers with Evergreen Storage. Before we dive into episode 3, let's recap episode 2 quickly. In episode 2, we showed the non-disruptive hardware upgrade from the FA400 series to the new FlashArray M series. The upgrade was performed with a variety of different application workloads, such as Microsoft Exchange JetStress 2013, SQL Server 2014, both OLTP and DSS workloads, along with Oracle 11g DSS workload. In episode 3, these same workloads continue to run on the FlashArray, so we can show the next non-disruptive upgrade of hardware. Let's get started. Before beginning the hardware upgrade, we can check the view of the FlashArray web management interface to see that our application workloads are still running without interruption. We can also take a quick view of the two SQL Server instances via the SQL Server Activity Monitor. SQL 1 and SQL 2 are showing an OLTP and DSS workload respectively. The SQL 1 instance shows that the database I/O is approximately 765 megabytes per second, and the SQL 2 instance is driving 185 megabytes per second. To start the hardware upgrade process, we first check the mode of the currently connected controller using PureDB list mode. This indicates we are on the primary controller. We set an alert flag using Pure Alert tag timeout of 240 minutes, specifying maintenance. This indicates we are performing a maintenance operation on the system. The first controller that will be replaced in the system is CT0, which is secondary. To ensure we are working on the correct controller, we set a hardware attribute to identify CT0 using the Pure Hardware Set Attribute Identify On CT0. This operation shows an indication on the front of the controller to verify the identity. As part of the Pure Storage platform, customers' FlashArrays use the Pure One Phone Home feature for continual monitoring of the systems. For this upgrade, we are sending today's phone home logs before starting any of the physical work on the system. We issue PureArray Phone Home Send Today to start the task, and we can issue a watch command to see when the task has completed. With the phone home task complete and the controller identified, CT0, we can begin the hardware removal process. There is no shutdown process for the FlashArray M except to simply remove cables and then the controller. The next sequence of events are to remove mini SAS connections, fiber channel cables, Ethernet, and finally unscrewing the secure screw which keeps the controller in place. The trickiest part of the upgrade is making sure the cables are not in your way. Switching over to the management interface, you'll notice the new alerts: CT0 cable failures and CT0 failure. These are because we removed the CT0 controller and all of its associated cables. You will notice that the CT0 controller goes from green to red, and the CT1 controller changes from yellow to green. Now CT1 is servicing all I/O to the FlashArray. During this process, it's important to point out that we have no disruption in IOPS, latency, or bandwidth. The next step is to add the new FlashArray M50 controller in the CT0 slot and reconnect all the cables. We connect mini SAS cables, fiber channel, and last Ethernet. Switching over to the FlashArray web management interface, we see both controllers are now online. Opening up a CLI session, we run the hardware config-m to show the model of the CT0 controller. Notice that it is an M50. This is the controller that was just added to the system. With the new FlashArray M50 controller installed, we begin the software portion of the upgrade. We start by running Pure Setup Replace from controller FA-M20. This will start the Purity Setup Wizard and check SAS cabling and controller links are OK. We set the time zone, confirm that change, and Purity is restarted. Once Purity restarts, we receive a confirmation that Pure Storage is online and the secondary controller is ready for use. The FA-M20 CSG NDU CT1 is still the primary controller. Switching over to the web management interface, we can see that both controllers are online, which is indicated by the green lights on the controllers. A quick view of the SQL Server instances shows that database I/O is still running. Now it is time to replace the remaining M20 controller, CT1. We connect to the controller and verify identity for safety using pure hardware set attribute identify on CT1. Checking the front of the controller will visually identify it as CT1. Once again, we send the phone home logs from today using pure array phone home send today. Now we remove the remaining M20 CT1 controller and add the second M50 controller. Again, we remove mini SAS cables, fiber channel, and Ethernet, along with unscrewing the security screw. As previously mentioned, the tricky part is ensuring the cables are out of the way when you slide in the new M50 controller. Now reconnect the mini SAS cables, fiber channel, and Ethernet to bring the system online. We connect our remote console to the new CT1 controller to perform the Pure Setup Replace from controller M20. This again starts the Purity Setup Wizard and checks SAS cabling and controller links are OK. We choose to change the time zone, confirm that change, and Purity is restarted. Once Purity restarts, we receive a confirmation that Pure Storage is online and the secondary controller is ready for use. We check both of the controllers using Pure Array List controller to ensure both controllers are M50 and have a status of ready. The next step in the process is to add capacity to the system by adding drive packs to the FlashArray M50 chassis. This will provide additional capacity in addition to the already existing external shelves. We remove the FlashArray M faceplate and then remove the blank drives that are in the chassis. Once these are removed, we add the additional drives to the first set of drive bays. Switching over to the web management interface, we can see the newly inserted drives show up as yellow. This is an indication that the system has recognized the drives and are adding them into the system. As the drives are recognized, they go online as indicated by the green status of each individual drive. Notice that as the drives come online, the total capacity of the system increases. After the first drive pack has been added, we perform the same steps by removing the blanks and adding another drive pack. Again, the drives are recognized as shown in the web management interface, and the capacity of the system continues to increase. We now have a fully populated FlashArray M50 chassis with 2 external shelves, all without disruption to the running workloads. In conclusion of the video series, we showed non-disruptive upgrades of the following: Purity operating environment software upgrade, generational hardware upgrade from the FA420 to the FA-M20 model, in-generation hardware upgrade from the FA-M20 to the FA-M50 model, and finally adding capacity into the system. All of these actions were performed with active workloads and did not cause any disruption. This concludes the Pure Storage Non-Disruptive Everything video series, and we hope the 3 videos explained just how easy it is to upgrade our system and to see the value of evergreen storage.